Welcome everyone. Today we have our another new episode. This episode we're going to discuss about 2D to 3D converting devices. This is very important. I can remember we have another show before on 3D printed, and I think that show was very popular in Asia Pacific. I think Mr. Rob actually brings many interesting idea and example. So I'm sure for today's 3D sessions also very important and interesting for our audience. We have our world famous speaker, Professor Rob, Mr. Raymonds, and Madam Victoria from Russia. So it will be very interesting session for us. I want to start from Victoria. So how you want to share your views about 3D converting devices and what is the present situation right now in Russia?
So we usually here use it as for game dev, and as I see that we do not use here 3D devices for business initiation, but there are a lot of vendors who are working in the game industry, game dev industry, and what I see as a trend that, for example, Diamond is here, organize his usual conference, and for those people who couldn't visit his conference offline, he proposed some 3D visualization version. He even sent some Oculus devices to watch the press conference in other visual format.
Thank you, Professor Rob. This is very important topic. How you want to share your experience and views about 3D printing?
Well, so 3D printing is called or referred to as additive manufacturing by the industry. We have several layers of 3D printers. We have a consumer market that's emerging for hobbyists and individuals that like to build things that otherwise would just exist in their imaginations. And then we've got an industrial level, largely dominated, at least the largest company that I follow in this space is Hewlett-Packard, that uses additive manufacturing to a large degree in mostly the automotive market. And the advantages to the technology have been improving. Initially, most of the things that were 3D printed you could use for prototyping, but you couldn't use for production. They were relatively fragile, not very attractive, and more of a experiment in what the technology could do. It's evolved since then. Now you can build parts that look like they've been manufactured. The cost is less than short-run manufacturing, and certainly as we've moved into metals, a lot cheaper than CNC machines or metal sintering, and both are very expensive. A few years back, there was a company that was showcasing that they could build a handgun using metal sintering, and they did. It was a match-grade handgun. It was a gorgeous usable weapon. The only problem is it cost 10 grand to create, and if you went to the store and bought one at retail, it would probably cost you closer to $1,000 than $10,000. So it showed there was a significant difference in the cost of building the two devices using two different methods. But since then, 3D printing has entered the space and lowered that cost rather dramatically for metals. Next stages are mixed mode. By the way, I should mention we have moved into color, though color still seems to be hovering more on the prototype than the production side for multiple colors. You can always change the medium and get a solid color, but doing multiple colors, for whatever reason, seems to degrade the result to a degree where people are more comfortable using it for prototyping than actual production, but that'll change over time. And as I say, the next mode is multi-mode 3D printing, where you can combine different materials to create an object. One of the other areas where 3D printing has made huge inroads is with prosthetics. The use of 3D printing for prosthetics has been revolutionary. It's both lowered the cost of the prosthetics and it's increased the usability of it. Typically, prosthetics were built kind of generically, sizes like shoes, and that meant nothing fit anybody particularly well. With 3D printing, you can design the prosthetic for the individual, and if you're talking about a child, you can grow the prosthetic over time through replacement to match the child's growth, comparatively inexpensively to what it would have taken to craft a prosthetic and make those same changes throughout the child's growth. So this is a major area of development. Long-term goals are really to turn factories into large 3D printers. The NVIDIA at GTC this week is showcasing the application of artificial intelligence and automated manufacturing to create factories that largely have no people in them. The robots move the materials around, the robots build the vehicles, and can implement high degrees of customization without the labor penalty that typically results when you have a labor-focused manufacturing plant. Companies like BMW, for instance, are moving aggressively to this technology as they see it's a competitive advantage, both lowering the cost of the vehicle and increasing the flexibility of the build so you can more customize the vehicle to the individual. We don't really talk about these automated factories as 3D printers, but the end result is for the most part, you're going to put materials in one end and get finished goods out the other. And that's probably the ultimate end for 3D printers, where you'd have 3D printers inside and on the lines and be able to shift models on the fly as opposed to doing major line overhauls, as you typically have to do to move from one vehicle to another. Another benefit is shortening the time it takes from design to manufacture, which for the automotive industry was typically 5 years. And now with these modifications is dropping closer to 2 years. So this technology has a major influence on manufacturing. And one final thing, being able to build parts for aging equipment, where it just you can't justify the cost of bringing back up a manufacturing line for a handful of parts. 3D printers fit in here nicely. While they're more expensive per part than high volume manufacturing, since you're not doing that in this case, they're far cheaper than trying to bring up a line or manually craft a part as opposed to just 3D printing it. So it's having a major impact on manufacturing, mostly in automotive and prosthetics, but it's moving to other industries as well now.
Thank you, Professor Rob. Mr. Raymond, so what's your view about 3D printing?
3D printing, well, I have very, very much a layperson's view on this. The one device that I've had a little bit of third-hand experience with is, well, he was a 3D device, who was a rotoscoper and matte painter for Lord of the Rings, the movie. So they're going from the 2D images that the matte painters paint. So they do these massive landscapes, generally very, very realistic, quite detailed, very, like the quality of work was beautiful to see. And then what happens, that gets transferred through via Weta Digital into the 3D format. So obviously the development of those Lord of the Rings trilogies, there was huge numbers of artists working, lots and lots of hours. It was really interesting. I was just quite fortunate to be able to, my ex-wife was working with Weta Digital on those 3 projects. So we were quite close to a lot of the different artists that were taking works directly from the book. So then seeing them in this 2D format, the drawings, actually going through that whole process from being a pencil drawing to a colored matte painting, then being rotoscoped. Excuse the cat in the background. Then being rotoscoped, which is actually when they create depth from that 2D image. So it's a lot of that was all hands-on. It was all done manually. I mean, and for me, it's amazing to sort of see that we've come from that over the last 15 years, or you go back even further to Walt Disney, these initial types of animations and cartoon storytelling, to where we are today. It's impressive. The other thing with regards to the 3D printing, I think it's amazing. I mean, in China, we've seen it. They're able now to produce whole buildings in very, very short periods of time. So the technology, the leap of technology, I'm just astounded with over the course of the last 20 years to going from quite, if we look back now, very basic 3D effects for movies to now things that you really cannot, unless if it's very, very well done, you cannot tell the difference between what is the real version and the filmed version, and what is something that's been created from the digital artist's workshop.
Thank you. Madam Victoria, I have a very basic question for you. Which industries use 3D printing and what are the benefit uh, of 3D printing? Victoria, can you hear me? Sorry, in that situation, oh,
Yes, we have some problems with the connections. So I suppose that yes,
okay.
according to the latest trends, 3D printing is one of the big trends of the next year. So it's the rising year and the rising investment right now. In any case, and interesting investment opportunity for the target audience, of course. But if we are talking about mm, uh, where we could these technology could be suitable. I know that a lot of people make some investigation and researches inside 3D printed of in medical research, in human organs as well. So yes, of course, we have in Russia such researches, but I'm not sure that we have some surgery right now with the 3D printed organ. In any case, this technology also used in architecture and as to build some modeling to make some 3D modeling and yes, some buildings, some as well.
Thank you. Thank you, Professor David Smith, for joining today's session. Professor David Smith, can you hear me?
I can,
Okay,
yes.
we are discussing about 3D printing. So, can you share your views about 3D printing? Yeah.
Yeah, 3D printing has really begun to reach the early part of its inflection point. Um, most technology needs to hit about 5 to 7% of the market size it can be to begin to go to completion. And if you begin to look at some of the forecasts for this whole 3D area, it's expected to really begin to take off and is expected to grow from about $14 billion during 2020 up to around $100 billion by 2028. So there's a lot of growth room going forward in this area. And the applications are uh, really very mind boggling if you begin to think about it. Um, in my hometown here in Austin, Texas, we actually have a 3D printed community being built right now that every home in this subdivision will be 3D printed there on location. Um, Very interesting um, view of it. In one of the technology groups I'm a member of, we actually had the developers come in and spend time with us. And some of the unique things you can do with 3D printing are very, very interesting. Of course, it's being used in healthcare, being used in manufacturing. Uh, Most of the maker fairs around the country have 3D printers there available to use. But the software to enable 3D printing is really becoming of age. You know, you can begin to find specialized programs, but many of the CAD programs and other things are now being updated to have 3D printing capabilities built into the basic CAD programs as well. So it's really a market that's beginning to get its own legs. It's reached the past where, as a forecaster, we see it going to what its market potential will be. And that's really a good sign.
Mr. Rob.
Well, a lot of interesting coverage so far.
Can you hear me?
Yeah. Oh, can you not hear me?
I'm here.
Oh, hi, Kimberly. Can you hear me all right, Sharif?
Yes, I can.
Okay, good. I don't know if Sharif's frozen or not, but anyway, so a lot of interesting stuff that we've talked about so far. Raymond brought up movies, and what's interesting is already the technology he spoke about, the ability to print large, accurate backdrops, has been replaced by LED walls. Which is typically what you now see in the latest Avenger movies. And the neat thing about that is actors can now interact with the environment, where previously these backdrops were relatively static, and so it actually puts you in the action, and suddenly the monsters you're trying to emote against are there and at scale. So that it really helps the actors and creates a much more realistic environment for the moviegoer as well. There's a lot of advancement. David Smith brought up the idea of 3D printed houses. I know we've talked about this before, with huge advantages in terms of labor. Up to a 90% reduction in labor and up to a 75% reduction in time. Most of the time just goes into plumbing, wiring, and finished carpentry. The structure goes up incredibly quickly, and if you have a disaster or a problem, 3D printed structures are undoubtedly better, particularly in areas where they're having weather events, than say mobile homes, which are very vulnerable to weather events. And so you could have a situation where you have an area that's wiped out by a weather event, you put in mobile homes, and the next weather event wipes them out as well. That doesn't happen with 3D printed houses. They're relatively robust, and they can be designed without the hard lines that a typical wood frame house has, so the wind flows around the home as opposed to hitting a hard surface that is part of what causes the structure to collapse. And also, because a lot of the homes collapse because of overpressurization, you can build the structure in a way that the windows are less likely to fail, because you build the structure as a cohesive whole, as opposed to something that might flex, and that flex can open up gaps in the walls, allowing wind to come in and creating the overpressure event, blowing out a window and then causing the house to explode. So a huge number of advantages to the underlying technology. Victoria brought up the idea, the concept that I'd forgotten about using it in surgery, using 3D printers to create things like joints, valves, things that you can implant inside the body. Once again, the advantage of 3D printers is you can build highly customized parts for not a lot of money, and the end result is applying that to something like a prosthetic or a medically inserted device has huge advantages, because rather than having set sizes, and we are not set sizes as people, we have unlimited variability, and so being able to design a part cost effectively for the individual means that part will fit them better, it'll be more comfortable, and it won't give them the problems that a typical milled or manufactured part would provide. So it's got huge advantages for the medical industry. So it's brilliant stuff. And as we move through the different concepts of additive manufacturing, this idea of being able to highly customize things that we can't customize right now because of the cost comes to fore, and that's a way that one company can differentiate against another, providing something at scale that is customized for a far lower cost than would take to build that thing using manual labor. So it's a revolutionary technology. It's nowhere near its peak. We're still exploring a lot of the areas, and as we move to multi-mode 3D printers, the printers that can print using plastics and metals at the same time, and then eventually move into being able to print complex objects with electronics built inside during the manufacturing process, is probably something we're not going to see until after 2030. We really have the opportunity to do things like allow people, granted first in the wealthiest households, to print the devices and things that they want for their household use. That'll be another revolution that's in our future. But it's an area that's disrupting manufacturing, it's disrupting home building, It's disrupting prosthetics. It's disrupting medical devices. Oh, and one other thing, there are ceramic 3D printers, and you can actually print jet engine parts with these printers on the fly, which has been handy in keeping the older jet engines in service much longer than their useful life would have allowed. They're little eddies in this market where people are creating some very unique solutions that may not be the high volume or the highly visible items that we typically see, but are having a massive impact on their related industries, and the ability to keep a lot of equipment that otherwise might end up in landfills or junkyards on the roads, in the skies, and functioning both safely and inexpensively.
Thank you. We have our new guest, Madam Kimberly. So how you want to analyze today's topic, and if you share your views with our World Talent Economy Forum audience, that will be great.
Well, I'm just getting in kind of on the tail end. I just came into the office, so I'm just listening. It's very interesting. So everybody just keep talking. It's 8:25 here in the South a.m. So I'm still waking up, having coffee.
Okay, no problem. Mr. Raymond.
Thanks, Sharif. I love the serendipity of things, and like metaphysics, and like I was talking about Gino, who's an effects artist that I met in New Zealand. Can you hear me? Sorry. He was an effects artist. He was actually the guy that invented Freddy Krueger from the horror movie, and now he's creative arts director for Weta Workshop. So this whole Weta world of like visual arts and filmmaking and stuff. Gino got me thinking about a young Argentine here in Buenos Aires, whose name is Gino Tubero, I believe. And we're talking about prosthetics, and like the cost of a new prosthetic arm can be in the tens of thousands. He took it on his own back to build his own 3D computer, and he started printing prosthetics for children in lower economic sort of tiered environments, and he was producing these prosthetic hands for children for as little as $15. So he's got like thousands of people on the waiting list just to get the real basic prosthetic, and then if they wish, if they can come up with the extra money, they can get an upgrade so that they can go fishing, but they can get the basic thing for as little as $15, which is amazing. He was so notable with what he was producing that when Obama Barack visited Buenos Aires, he made a special point of visiting the design labs here in Buenos Aires. So it's really interesting what people are doing with what they've got. There's always a way. If the intention is there, people will find a way. So, yeah. Thanks.
Thank you. Victoria, I have different questions to you because you are also a woman entrepreneur who are doing work in Africa with WTEF. Even we have a good news. 1st December, we will launch one of the largest public-private partnership dialogue with Rwanda governments. I think 12 ministry. Today we finish our collaboration, our MOU, as well as all of the large corporations and the academy and different ambassadors. They also join in our event. One of our major issue is women entrepreneurship. So what do you think, this 3D printed and this kind of new technology, how it will be helpful for women entrepreneurship and how they get benefit from this kind of new technology? What is your views, and what is your view from Africa? I know recently you visit Africa. Yes.
I don't know. I suppose that there is no woman entrepreneurship or man entrepreneurship. There is just entrepreneurship. Because we have the same rules here, and business is strict structure that you should build. Talking about footprint, we should remain that right now a lot of dentists use these technologies in 3D printing of dental crowns and bridges and implants. So it is some sort of working technology right now, and it's used in dental printing. It's, I know that in Moscow it is also used, and of course in the big cities in Africa as well. So yes, it is some of innovation in the surgery, but if we're talking that a lot of doctors are women, yes, it is women entrepreneurship. But I wouldn't. I don't know. I don't think that there is some women entrepreneurship or men entrepreneurship. There is just entrepreneurship. Of course, we still a woman and man, and we have some differences in a case. And a lot of women, I know a lot of women, a lot of girls who are working with the scientists who are scientists and who are working in IT industry, so or advertising industry. So sorry, here I couldn't say something new. So
Thank
in entrepreneurship, of course, it's some sort of technology that should be used, and where we could invest our money as entrepreneur. Because it's the rising area, rising investment.
Thank you. Madam Kimberly, if you want to add some point about women entrepreneurship, I'm from Asia Pacific, even few countries, prime minister also women. But example, definitely industry 4.0 always this kind of strategy encourage women for entrepreneurship, economical sustainability. What's your view? Because in Malaysia, Indonesia, Vietnam, Singapore, there are many women, they are taking initiative. They're developing startup and 3D printed, definitely new opportunity. What do you think?
It is. I think the world of movie talent, even in LA, everywhere, is still uh, pretty much man based. So breaking in as a woman um, is getting some easier. I know my last two small films, we did a lot of 3D graphic. I learned so much. And I think it's pretty incredible that the women directors that are coming out now, um, it's just, I really like what I'm seeing in the industry now. We're getting very versatile worldwide, which is incredible. So I'm always happy whether it be male or female to see success. And between the medical situation, with COVID, there's been a lot of drawbacks in the industry because of that. But I think we're coming back. I'm in a medical clinic now, so I see the COVID numbers dropping, but I've been noticing that the film market's coming back, especially in LA. Movies are beginning to be made, theaters are opening. So if, I love, the industry. I love movies. I'm more of an author, and then I make my books into screenplays. But yeah, I think it's really great what's going on right now in the world. And as far as women, I think they bring a lot to the table, a lot.
Thank you. Professor David Smith, I have a specific things because Asia Pacific, there are a lot of, I want to say, construction industry growing very fast, especially new cities, new manufacturing hub, new even automobile industry, many things growing even in developing nations, and it's growing very fast. Do you believe that if this 3D printed industry grow in Asia Pacific, that they have to restructure the like infrastructures, manufacturings, and all of the industry, or what will be the future actually?
Well, great question, Sharif. I think a lot of the 3D printing, the 3D capabilities will be incrementally added into industries, and will be able to build and convert as you go through your process. You know, part of the other place in the manufacturing industries and those that you mentioned, where 3D printing is often tagged together with augmented reality, because as you begin to prepare your objects to print 3D, as you begin to do it, you can go through the 3D modeling and begin to optimize out the processes that in the traditional manufacturing process, you would go through small lot production runs to make the product better before you went fully in production. And 3D printing and 3D modeling, and even 3D use within augmented reality is shortening this time very far. The other thing it's doing, Sharif, is that 3D printing is allowing us to change the targets we have in manufacturing, the targets we have in manufacturing in most of the industries. In the past, as you use traditional manufacturing approaches, you really wanted to hit a mass market size. And it was very hard to do customization in the old mass market manufacturing approach. I don't care if you're building watches or if you're doing implants. Uh, Many of them were produced in mass market format. Now, if you look at uh, knee implants, other things like that, they were all done in more of a mass market manufacturing approach. What 3D printing has done is to allow us in many places look not only at small markets, but look at the concept that's called a market of one, where you can begin to customize what it is you're manufacturing, what it is you're producing to the consumer that you're working with, because you do not have to have these long production runs. You can load the images into the 3D printers and have them produce them as you go there. That is why, for example, on the International Space Station, many of the repair parts up on the ISS are done with the 3D printing that is on board there in orbit. And you're beginning to see this. If you look at what NASA has in plan with the moon mission, but even more importantly, the Mars missions, 3D printing is an integral part of their planning of not only to get to Mars, but to create the habitats on Mars. And it will be built there using 3D printers and 3D printing techniques. So again, it's really changed how we look at these from very much of how can I optimize my manufacturing run to produce as many of the same things as I can at the lowest cost, to being able to produce more of the market of one in the small lot productions.
Thank you, Professor Rob. Because regularly, World Talent Economy Forum, we have to deal with different developing nations, especially the government and corporations. COP26, after the feedback, like this political discussions and everything, we can understand that still it's not clear about policy development. Why I'm discussing this point? Because the developing nation example today I do discuss with the Prime Minister office in Bangladesh, and the major challenges this kind of technology, they need to develop research centers like any kind of industry development or research collaborations and partnership with the local ecosystem. These are the major things. Professor Rab, you work for one of the all of the largest technology company from Silicon Valleys and from USA. So what is the views, like example, when the developing nations thinking about that they need more support for industrial research, they need more collaboration for industrial research. On the other hand, developed nations, still there are a lot of policy, this and that. How we can develop a better strategy? Very simple. How we can develop a better strategy for doing research, example, on 3D printing issues with the help of developed nations.
So, well, first we start off by saying that you don't start with a solution and back into the problem. You start with the problem and work towards the solution. 3D printing for developing nations is probably not an area where they want to do a lot of R&D because there's a substantial amount of R&D already going on in the developed nations, and the technology is fairly well advanced. So trying to catch a developed nation from behind by a developing nation, that almost never happens. But the developing nation can make use of the technology. 3D printing does allow the nation to build more things at higher tolerances locally, so they don't have to incur the shipping costs. They can better structure the pricing to their environment, and they can fill the needs of their local community much more quickly and aggressively. We've been mentioning prosthetics several times here, and a lot of times medical capability just doesn't reach the developing nations to the same extent that the developed nations have it. We're certainly seeing that play out with regard to the inequity with regard to vaccines at the moment. So that what you have to do to address this is you have to bring the manufacturing in country. Because if it's out of country, the countries that are making the stuff that have a great need will consume that stuff, and it won't make it out of country, and it won't make it to your nation. Plus, when you're at manufacturing, when you're a developing country and you're buying stuff from a developed country, you not only have the relatively higher cost of labor you're paying for, but you have all the transmission costs, the logistics costs, the other things that you have to incur that the developed nation can afford, the developing nation cannot. So here's a case where 3D printing really is less about R&D effort and co-development and more about the application of that technology to keep the costs of what that nation needs low enough so that the nation can make use of them. I'll give you an example. There was a program that was done in Africa. I've mentioned this before with regard to developing wells for a number of the communities that were having trouble with clean water. Bill Gates called this out a long time ago, that you really, in a developing nation, if you don't have clean water, if you don't have access to food, and you don't have access to medicine, the developing nation is not going to be out buying computers. Those primary needs, going back to Maslow's hierarchy of needs, are going to consume much of their money and ecosystem, and the end result, they won't have much left over for the other things that we consider in the developed world as staples, but in the developing world might be considered as luxuries. And so what you have to do is you have to go in and analyze the underlying problem, and then you have to have a technology that can work in the environment, and then use that technology in the environment. So in a lot of the developing nations, even supporting a 3D printer at this particular point might be problematic because they don't have the infrastructure to do the support. So we're far away from the capability of being able to do an R&D in the product. The short-term need is to develop the support infrastructure so that 3D printers can be brought in to produce low-cost, low-volume items like prosthetics that help the workforce keep people productive and increase the GNP for the country, so they have more money to do the other things. You don't want to jump too fast into the expensive side of this market when you don't have the money. You have to focus on building up the infrastructure and the economic capabilities of the country first before you can afford these more expensive efforts. So with regard to 3D printing, it's advanced enough so that you could begin to apply it. But if you are going to apply it, you have to first develop the infrastructure to support it and start talking about what custom applications might be needed to adapt the technology to the underlying environment. Now, before I leave you, I did want to showcase, just to give people an idea of the kind of thing you can 3D print. This is a rocket prototype. I mean, it's actually a movie prop, but if you see, it's the level of detail, the ability to show the metals, even the internal fan and the depth of the device is highly realistic, and that's why this stuff is currently being used very aggressively in prototyping. And then David Smith highlighted something else with augmented reality and virtual reality. You can create prototypes without using materials, which might actually be better in an emerging market than using a 3D printer and creating a hard object, because it's less resource intensive. And a virtual object doesn't have to have environmentals. You don't have to preserve it. You can maintain it digitally, and once again, might be a better path for certain types of prototyping than 3D printing is, because 3D printing adds a layer of cost that augmented reality and virtual reality don't have. But you start with a problem. You craft the solution to the problem. If you start with a solution, invariably the solution will be suboptimal because it doesn't address the problem until way too late in the process. And the end result is you get something that doesn't fit in the environment you want to place it. So first step is to analyze what it is you want to do, and then find and adopt the technology that most matches to what you need done to the problem. And that way you have the lowest cost, highest effectiveness of the underlying effort.
Guys, I hate to leave. I've got patients to see. Thank you so much for the invite. I've enjoyed it.
Thank you.
And,
Thank you, madam. Thank you,
I
madam.
wish you all a good day.
Thank you.
Bye.
Thank you.
Really.
Bye-bye. Bye. Mr. Raymond, yes.
Just to pick up on what Rob was saying, I think it's quite interesting. We're talking about prosthetics, and let me thinking about the no pun intended, the arms race. The printing of things such as rockets, or for like use against, or you could argue to protect countries, is going to be quite interesting as we move into the future. I also wonder about the as we're already using not just plastics, we're using metals, fibers, as we become more knowledgeable with regards to our own genome and other plant lives, how this will translate in the future to, like we've seen years ago in science fiction movies, the printing of foods, which is probably one of the applications that NASA's probably already working towards, the printing of foods, and therefore we have we're going to run out of space on the sides of product boxes for the ingredients. Instead of the ingredients, we have, okay, well, what is this actually printed with, and how is it affecting our physiology? So I think there's really interesting conversations to be had in the future as we move forward with printing, not just for things we utilize, but also for things that we may end up ingesting.
Thank you. Victoria, actually, like different views actually coming in terms of 3D printed activities, development and R&D development. What do you think in terms of Russian cultures? So what happening inside Russia, especially 3D printed based technology development or R&D developments? And what I know that Russian government, they have a strong collaboration with the developing nations. Even country like Malaysia or India or Bangladesh, they are actually doing some largest project. Even they are also investing right now, this kind of country. So what's going inside the Russian economy, especially when we discuss about this kind of Industry 4.0 related research and development?
Yes, we have several startups that are working inside this industry, and of course we have some of them work with Skolkovo. It's like some Silicon Valley in Russia. I know that it's not so. The level of the Skolkovo, of course, not so high as Silicon Valley startups, of course, to say. In any case, some patriotic startups, and in this case, you couldn't be every time. Every time it's about more about lobby and politics than about startup culture. But we have some several researchers inside this industry, of course. Most of all targeted not only for Russian market, but for development or negotiations with the Asian market and with the European Union market. And of course, if we're talking about some leaders, the leaders of the industry, of course, we are situated in Asia, in China, and if we're talking about some partnership, the partnership with Asian companies. First of all, as American-based market, I know that a lot of startups from Russia want to work with American-based market. But if you're working with the other culture, you should locate your startup inside US, and therefore you stay like sort of international startup or American-based startup in any case, not Russian startup. So that is really interesting.
Thank you. Professor David Smith, you are actually a CTO for one of the technology company, ETT. So, and I know that you do a lot of projects and work with the developing nation like Pakistan, like Bangkok, even Indonesia, and many countries. Actually, when you engage with business joint venture or partnership, like your company help for research and development, I know personally there are many local company, financially they are very capable for doing research, and these things is very important for at least a sustainable ecosystem development. What's your view as a CTO of your company?
Actually, good question there. It is to phrase what you're talking about, in particularly a developing nation. The area where 3D printing excels is adapting it to many different vertical domains. I can adapt it into the entertainment industry, the housing industry, manufacturing, into healthcare, into aerospace. And it's that unique ability for this technology to be in so many different domains that makes it in a place where developing nations can take advantage of it. I actually agree with Rob in the fact that the basic hardware is getting premature. And the reality is it's pretty expensive to do hardware research and development that can do things at the scale we're seeing now in 3D printing. The International Accelerator, which I'm one of the board members at and a mentor at, we recently brought into the accelerator a new company that is focusing on 3D printing in the aerospace industry and is producing parts now for several of the largest airplane manufacturers. Their secret sauce, and this was developed in, I'm trying to remember, this company came out of Brazil. Their secret sauce was how do you put enhanced quality control into the materials that you're 3D printing? How do you, through the different nozzles and things, use, in essence, a Six Sigma approach on how to make the quality high? And how do you do that not in small areas, but over large pieces that they were manufacturing that had to have high tolerances to be able to work? Now, everything I said about what they did could be done in most developing nations, where they've taken the hardware technology and they've enhanced it with software, they've enhanced it with modeling, they've enhanced it with pulling other domains in, such as a way to precisely measure it as it's being built, using lasers and LiDAR technology and stuff there, and using other imaging formats like hyperspectral imaging combined with the 3D printing to produce a product that works there. All of those type of approaches are in the wheelhouse of most developing nations to use. So it's one where they can get into it. And entrepreneurship in developing products that use 3D printing should be almost a no-brainer today for budding entrepreneurs who want to get into something where they have to build a material, build a product. And the ability to model it first and then go into production and not have to go and retrofit huge factories is really a plus for developing nations.
Thank you, Professor Rob. Especially you are a very good business strategics, and there are many interesting things you always share with our audience. Especially, I love to learn more about the developed world, especially the large corporations, research and development issue, especially how much they invest, how they get the returns, how they solve the problems, especially the large corporation. You always discuss about IBM and Microsoft, and these are the corporations, because this will be very interesting guideline for our students. Definitely, we will utilize this content for the different classrooms.
Well, it varies company to company. IBM still uses the traditional lab approach, where they have a number of labs located all over the world that are doing research both on things that are connected to their business and things that are not necessarily. So, for instance, they're still doing research on innovative ways to create clean water, which could be used for cooling large plants, but is predominantly focused on providing clean water to people. And then you've got Intel that maintains a far smaller lab presence, but heavily leverages schools like MIT to extend that presence and create critical mass in their development efforts. It really comes down to the approach that the company has, and whether they want to be a market leader or a fast follower. Companies that are fast followers, like say Apple, don't maintain much in terms of labs that they pull from others, but it works very well for them financially. So, an emerging country probably should be less on the bleeding edge, which carries a lot of risk and carries a lot of manufacturing and innovation overhead, and probably should be more on the fast follower path, or moderate follower path, if you will, where they're looking at the technology developed by others and looking to license it and make use of that technology as it becomes available. That provides perhaps the best balance of resources and effective use of their existing intellectual material, people, and their existing knowledge and capabilities. There are other advantages to doing advanced research. One of the areas of rapid advancement right now is artificial intelligence. And we've certainly just had the emergence of the metaverse, which is projected to be bigger, at least in terms of economics, than the internet is. And like a lot of things, that we're in the hype cycle, so don't read too much into this at this phase, because typically the hype cycle over-promises and under-delivers, and then we get into production, and then we under-promise and over-delivers, and that's probably a good 15 years, if not 20 years out. But these are areas to keep an eye on, because they're areas that will have impact on how we do things and how we interrelate and how we collaborate. Collaboration probably is the one area where an emerging market company can do a lot of good, predominantly collaborating on helping companies bring technology into the region, and then doing value add, either with services or additive manufacturing within their own framework, in terms of adopting the material or capability to the country in question. In fact, for an emerging market company, perhaps the most lucrative area is that adaptation of an existing technology into countries. So they're not doing the heavy R&D, but they're doing focused R&D that is specifically focused on solving problems in the country where they reside and where they are most expert. There you get the best balance of capabilities, resources, and intellectual property for a country that is just coming into market.
Thank you. Thank you for your excellent analysis. Mr. Raymond.
Yeah, once again, really interesting to see what happens moving forward with regards to intellectual property rights from things that are coming from the metaverse. I see there's going to be some probable conflicts there in the future. I've been talking with a woman who's been very, very proactive with developing ashrams around the world, and is currently looking at moving into or trying to set one up in Belize. And some of the issues that she's facing is quite interesting, talking with regards to the the materials being used for printing. I think it was it you, Rob? You mentioned hurricane style or hurricane proof constructions, things that are sort of designed to withstand heavy atmospheric conditions and so forth. I think it's Deltec Homes. They do a hemp-based product, which will be interesting to see moving forward if 3D printing is something that can be used to further reduce the costs of construction, because I understand that using these hemp-based materials, the costs are already heavily reduced. So it'd be really, it's really, just in closing, it's just a really interesting time to sort of have all this technology at our fingertips. Yes, it's quite exciting. I see lots of benefits coming to emerging. I don't like to use the word emerging countries, but countries as they develop and become more sustainable in their own right, without relying on funding from organizations such as the WMF, etc. So yeah, thanks again, Sharif, for inviting me. It's been great as always.
Thank you. This is really great session for all of us. I just want to share more good news because in January we want to arrange one of the largest conference with all of the Muslim world countries. We will do something with the halal investment, and definitely I'm sure that it will be very interesting networking session as well as learning session for all of us. Already we are confirming like Malaysia, Indonesia, as well as India, Pakistan, Saudi Arab, UAE, some Muslim countries, they will support World Talent Economy Forum for arranging this session in January. So the government, largest corporation and academy, we definitely going to invite this January. And beside that, this December 1st, we have very exclusive session with Rwanda. Today we finished our collaborations with Rwanda government and Innovative Lab, those who focused on sustainable development goal. And definitely we're going to invite already they ensured that the Ministry of ICT, Ministry of Health, Ministry of Trade and Industry, Primary and Secondary Education, Ministry of Youth, Ministry of Defense, National Police, Ministry of Local Governance, Ministry of Agriculture, Ministry of Infrastructure and Foreign Affairs, with 15 embassy, they're going to join in our public-private partnership dialogue, which will be another one of the largest public-private partnership in Africa. And definitely we always support TEF initiative. I know that TEF also organizing something big in this March, and definitely I'm sure that our speakers, our honorable board of advisor, our scientific committee member, they love to contribute for the global community. So we are growing very fast, and thank you all of our speakers, those who always support World Talent Economy Forum, Professor Rob, Professor David Smith, Madam Victoria, Mr. Raymonds, and all of our hundred of speakers, those who always support World Talent Economy Forum, because your support is always valuable for the developing nations. We have millions of people, we can touch them, we can help them to improve their life, and this is the way we can develop a real ecosystem. And that is the main objective of World Talent Economy Forum, because we want to connect all of the talent people from developing nation with the help of developed world. And I want to give special thanks always all of the speakers, those who supporting us and those who like actually guide us, develop better strategy, inspire us. They are very valuable for us. So thank you for joining today's session. I want to request all of our audience, those who observing our show, please share our content as much as possible with your government, with your academy, and with your corporations. I directly want to go for the concluding remarks. I want to start from Madam Victoria. What's your concluding remarks?
Yes, we will also have conference next March devoted to trends, and I hope that we will visit your conference as well. So as offline, if it will be offline as well.
Thank you. Thank you. Professor David Smith, what's your concluding remarks?
Sharif, I love how you pick the topics for your programs and how they begin to have impact in so many different places and so many different ways for the government, for entrepreneurship, for academia and business to take advantage of what you're talking about. 3D printing, 3D software, the 3D modeling tools, all have a place to help societies, governments, nations advance. It's changing the paradigm of how we look at manufacturing, how we look at healthcare, how we begin to really look at new ways to innovate and new ways to innovate rapidly. Um, it's kind of interesting because Rob mentioned earlier that many of the mainstays in the industry, like IBM with the IBM Research Labs, you see that in places like the Intel labs, where I still do a fair amount with, and others, are gradually supplementing the large labs with more innovation approaches. Many of them have innovation centers that actually will go out and fund promising research, fund promising early stage development of products and services. 3D printing is a great way to begin to put yourself in a place to create those type of relationships that can help you very rapidly move into larger scale markets and do things like that. The same innovation centers are creating relationships with universities and colleges. And increasingly, 3D printing is used in the research labs and development labs there. The major research university in my town here is the University of Texas. And they actually were one of the first ones to develop 3D printers that could manufacture whole walls in one run of a 3D printer versus having to build it layer by layer by layer by layer. So there's still a lot of research happening in that area, a lot of promising development, and 3D printing is here to stay, and the market caps will continue to grow.
Thank you, Professor Rob.
Well, one of the interesting things with regard to 3D printers for an emerging market country is the fact that most of the firms that are using these things heavily are relatively small. The additive manufacturing market is dominated by relatively small companies that are doing the work. The 3D printers are used for short-run projects, which means highly customized stuff. Etsy, which is a online service that actually built that rocket pack I showed earlier. At least one of the subscribers built it for me. Is full of people that print whatever you want using their 3D printers, and the work is pretty phenomenal and very affordable. And so for an environment that doesn't have a lot of large manufacturing capability, but has the capability to bring up a lot of really focused small shops, used to be with a lot of hand labor. 3D printers can be adopted to that environment if you take into account the environmentals and probably modify the hardware a bit so that it will survive in those environments, because a lot of the places don't have air conditioning. They have wide temperature swings and may be relatively humid, and much of the equipment out there won't survive that. But you can modify the equipment or create containment so you can place the equipment and have it used relatively effectively. It's kind of an ideal technology for a smaller country or country that doesn't have a lot of manufacturing capability, because it lends itself to short-run, small shop kinds of investments. And the end result is it could be transformational, allowing a relatively small economy to be able to deal with problems like maintenance that they're having trouble with right now with logistics problems, because logistics is kind of chewing everybody up right now. If you have an old printer, getting a part for that printer in one country when that printer's been out of service in the country where it was manufactured is going to be problematic. First locating the part and then getting the part shipped to you could take more time than you're willing to spend. But if you could 3D print that part locally, you keep the stuff running and keep those particular facilities in production. So 3D printing in an emerging market environment is particularly useful. And we mentioned the 3D housing stuff. We're certainly seeing a lot of building catastrophes that are happening in a lot of these countries due to improperly mixed cement, improperly reviewed or tested structures that are failing en masse. We're having some of that happen here too, by the way. But the 3D printing could provide a way to better build structures using low-cost materials. Raymond mentioned hemp. One of the other materials that's now being introduced rather broadly is straw, which is what's left when you harvest wheat. Something that's thrown away, it's burned, it currently compromises the environment, it doesn't help it. Now we've got factories coming up that are making paper out of straw, that are using straw as part of their building structure because it has a relatively decent insulation factor and will strengthen a polymer cement composite material that can be used to build buildings. So there are advantages to using 3D printers in an emerging environment that may actually exceed the advantages in a developed country, because in developed countries we have large-scale manufacturing, where in smaller countries or developing economies they often don't. And so the ability to use 3D printers to bridge those gaps and create the kinds of solutions that these economies need to keep their older vehicles. Well, take a look at Cuba, who largely drives around in American-made vehicles that were built back in the 40s and 50s. That keeping those things running is a huge problem for that nation, and yet with 3D printers, they could better self-contain that capability and keep those vehicles on the road and functioning. And let's add the one other thing, since you brought COP26 up. The idea of keeping things running and operational for longer periods of time so they don't end up in landfills or in the ocean has a huge positive environmental impact on the nation, because a lot of these nations are overwhelmed with trash and garbage. But if you could turn that trash, if you keep a lot of things that are currently discarded in production and out of landfills, then they're a benefit. They're not something that's polluting your water table. So it's got some rather big benefits for some of the countries that are struggling with a lot of issues, especially during this current pandemic-related logistics problem we're suffering through right now.
Thank you. Mr. Raymond, what's your concluding remarks?
Another great session with World Talent Economy Forum. It's touching all like this particular topic. At first, I was struggling to think how I could what am I trying to say? How I could add value to this session, but like obviously there's a lot with regards to 3D printing, with regards to sustainability. It touches on the supply chain innovation, industry, infrastructure. It is really quite impressive how broad on how it touches everything on such a broad scale. So very interesting session. Thank you very much for the invitation once again. Good afternoon, everybody.
Thank you everyone for joining today's session. This is really great session, and I'm really proud of with all of our speakers how Professor Rob, Professor David Smith, Mr. Raymonds, and Victoria actually analyzed the topics. This is the great learning for all of the people from the developing world, and that is the commitment we are getting from this ASEAN, especially from Arab worlds, from South Asia, from Africa, perhaps with all of the government bodies, with all of the corporations and the academy, we can make a very interesting forum, which will be for Developing Nations Forum. I know there is a G7, there is a G20. Yes, they're doing excellent work, but we want to raise voice from the real life people. So let's join in our revolutions. And I am very happy that 1 December we have a very exclusive sessions, and it perhaps it will be one of the largest African continent public-private real life dialogue real life project developments, and I'm sure our speakers' contributions will change millions of people's life. Thank you, Professor Rob. Thank you, Professor David Smith. Thank you, Madam Victoria and Mr. Raymond, for your continuous support for World Talent Economy Forum. We are growing very fast, and soon we will reach the millions of people life. Thank you. Bye-bye, and take care.